Okay, so what we're going to do is we're going to work on this integral. Now this is the same integral that we started with, but we're going to start from the beginning and approach this. Okay, and we're going to solve this and see what we get. Okay, so the first thing I'm going to do is, because it has the form, right, we're going to use our sine substitution because it matches this form. And so in this case here, this is going to be, our a is 3, right? And we're going to make the substitution of x equals a sine theta. Okay, so in this case here, x equals 3 sine theta, or in other words, sine theta equals x over 3. Okay, so now what I'm going to do is I'm going to set up the reference triangle right now. So let's set up the reference triangle. And so again, the way we're going to do this is opposite over hypotenuse. So this means this is going to be set up this way, and this leg here is going to be our 9 minus x squared. Okay, so there's my reference triangle because I know I'm going to need it later. So I have that there. So now let's go through and do our substitution. So this is going to equal 9 minus 3 sine theta squared, and then I'm going to have 3 cosine theta d theta. And so again, this is the same simplification that we did before. So I'm going to get 9 minus 9 sine squared theta, 3 cosine theta d theta. And then of course I'm going to factor out the 9 and take the square root of it. So I get 3, 1 minus sine squared theta, and then I get 3 cosine theta d theta, right? And then 3 times 3, so that's going to give me 9. And then I'm going to use the identity here, right? So this gives me 9 times the square root of cosine squared theta times cosine theta d theta. And then again, this is going to give me cosine theta, right? And so what I'm going to end up with is the integral of 9 cosine squared theta d theta. Okay, so that's where we ended up before, right? So nothing different. Okay, so now we're going to integrate this thing. Okay, and so this is where our powers, okay, come in. Okay, so now here's where I can't do the product rule, so I can't go backwards, right? I can't write that as 1 minus sine squared theta because I still end up with something I can't do a substitution. So I can't use the Pythagorean identity. I can't do this directly. Okay, so I'm going to have to use a different identity. So remember the other identity using that's derived from the reduction formulas. Okay, so the other one I'm going to use, and I'm going to bring it up here, and let me make some room here. I'm going to write this up here. Okay, so, and again, this is from okay, so now I have cosine squared theta. So the other one I can use is using this identity here. So it's going to be the integral of 9 times 1/2 that. Okay? Using the double angle identity. Now I've got cosine without the squared, and this is going to be easier to integrate. So now all I have to do is simplify this. And so I'm going to pull out the half. And so that's, oh no. I want to distribute the 9. So I'm going to get 9/2 plus 9/2 cosine 2 theta d theta. And then I can go ahead and integrate this term by term. Right? And if I integrate this term by term, then this will give me what? Oops. I don't want the integral sign. Gives me that, right? Now, I still have a problem with that double angle. All I have, oops, forgot. I have theta here. I don't have 2 theta. So, in order to use my reference triangle, I need things in terms of theta, not 2 theta. So I need to use another identity for 2 theta. So this is where you're going to have to beef up on your identities. You're going to have to know your identities. Okay, so start practicing, start memorizing them, do what you need because you're going to need to know these identities. Okay, so now I need an identity that puts things in terms of theta. Okay, and something that I can integrate. Okay. So, what's that identity? Okay, there we go. Oops. This should be 2 to the 4th. And so now if I simplify this, I get 9/2 theta plus 9/2 sine theta cosine theta plus c. Okay, so now I have everything in terms of theta. And so now I have to do my substitution. So now, again, this is where the reference triangle comes in. And now I've got to take this and rewrite this in terms of x now. Okay, so now theta, so now I got to put theta, so again theta appears by itself. So this is where the inverse function is going to come in. Okay, so how do I do this? Well, I use the fact that sine inverse of theta, right, or sine inverse, or theta equals the sine inverse of this. So I'm going to use the fact that If I take the inverse sine of both sides of this, I get theta equals sine inverse of x over 3. And so now I get 9 halves, right? So I get 9 halves sine inverse of x over 3. Okay, so we got that piece. And then what happens with this? Well, what is sine theta cosine theta? Well, sine theta times cosine theta. Well, what's sine theta? Sine theta is opposite over hypotenuse. So I get x over 3. So I get 9 halves, so let's put plus. I get 9 halves times sine theta. That's opposite over hypotenuse. So I'm going to get x over 3 times cosine theta. Well, what's cosine theta? Cosine theta is adjacent over hypotenuse. So I get square root of 9 minus x squared over 3. Okay? Plus 3. Or plus 3. Okay, so now everything's in terms of x. We're done. We just need to simplify, and we've got our final answer. So now I'm going to simplify everything. So this is 9 halves sine of x over 3 plus, now 3 times 3 is 9, so these are going to cancel with this 9. So I'm going to get x over 2, right? So this is going to cancel with 9. And my final answer I get is x, right? So my final answer is going to look like this. It's going to be x times 9 minus x squared over 2 plus c. And I'm done. That's it. So again, this takes some time. It takes practice. So make sure you practice these, and there's a lot of steps involved. But if you take your time step by step, it's very straightforward. Okay, it's actually not bad once you practice it. Okay, once you practice it, you start getting the feel of how to handle these, and it's just a matter of just writing it out and doing the substitutions, and then using reference triangle once you integrate and simplify. So the hard part is remembering the identities, okay? Is remembering, hey, I've got to have in terms that I can go ahead and use my reference triangle. So make sure you work on memorizing or knowing the different properties, different identities, okay? And then as far as the reference triangle, using the reference triangle and integrating, okay? Okay, that's it. So now let's give you one. Do I have one for you? No, I don't. No, I don't. Okay, we're going to go and do another one. So I'll see you in a little bit.